In this video, we will focus on basic integration. So integration is the reverse process of differentiation. For example, if we differentiate y, we will get dy dx. So if we integrate of dy dx, this is the reverse function of the reverse process of differentiation. So if we integrate dy dx, we will get back y. Second, this symbol is the symbol to indicate the process of integration. So next we'll look at integration of constant, algebraic function, trigonometric function, exponential and logarithmic function. So first we will look at constant. Generally, if we integrate a constant, let's say k, then this will be equals to kx plus c. Means that the numbers k just multiply by x. And then we have to plus c. For example, let's say we look at the first example. Let's say integrate 1 with respect to x. So here we should have integrate 1, so the numbers will multiply by x. So here is 1x plus c. So or we can write as x plus c. 1 times x is x. Let's say we'll move on to the second example. For example, integrate, for example, 2 with respect to x. So against the number 2 will multiply by x. So here is 2x plus c. So this is for the function. This is only for the constant. Next, number 3. Let's say integrate 1 over 5 dx with respect to x. So here 1 over 5 is also a constant. So what is going to happen here is equals to 1 over 5x plus c. Next, number 4. Let's say I try to integrate square root of 3. So again, square root of 3 is a constant. So here I should have square root of 3x plus c. So here is the example of how we're going to integrate the constant. Next, we look at algebraic function. So generally, if we try to integrate ax power of n with respect to x, this will be equals to ax, the index raised by 1. So it's n plus 1 over n plus 1 over the new index plus c. Let's say, for example, integrate x with respect to x. So from here, we know that this x actually is power of 1. So when I start to differentiate, if I start to integrate, so this will become x. The index will raise by 1. So it means that 1 plus 1 is equals to 2 over the new index is 2 plus c. So how about integrate x squared? So integrate x squared, raise the index by 1. So here will become x cubed over 3 plus c. Say next, I change to square root of x. So since this is not a constant, so what I'm going to do is from square root, I change to 1 over 2, power of 1 over 2. So here is equals to, so the index again will raise by 1 plus 1. You can use your calculator. So 1 over 2, although it's a fraction, we also plus 1. You can use your calculator. 1 over 2 plus 1 is 3 over 2. Don't forget to divide by 3 over 2 plus C. So if I bring out to the numerator, so here I should have, before this is 3 over 2, now will become 2 over 3x power of 3 over 2 plus C. Let's say number 4. Integrate, for example, 1 over x power of 3. Before I start to integrate, just like differentiation, what we're going to do is we will bring out x cubed to the numerator. It will become x power of negative 3. So from here, I should have x negative 3 raised by 1. So plus 1 is negative 2 over negative 2 plus c. So since this is a negative index, so what I have here is negative 1 over 2 x power of positive 2 plus c. I just bring this negative to the front. So it will become negative 1 over 2x squared plus c. Let's say number 5. I try to combine algebraic function with constant. Let's say integrate 3x power of 5 minus x plus 10 with respect to x. So from here, I should have 5 raised by 1, so it will become 3x power of 6 over 6. Differentiate negative x and integrate negative x. I should have negative x squared over 2. Integrate 10. I should have 10x. And then plus c. So here, if I try to simplify, I should have x power of 6 over 2 minus x squared over 2 plus 10x plus c.